But you see the frogs are chasing after those butterflies because they're hungry. We see some of the butterflies, they're surviving butterflies that don't get eaten are yellow. That's increasing, so there's way more yellow butterflies. Then once you guys logged into your own account, we went down to the code and you changed the flower colors, okay? So that's what we're going to start doing today with you and your partner. You guys have made a remix version of it, saved it in your gallery, so I'll help you get back there today.
You changed your number of flowers. That's part of the problem.
We have 25. Magenta got 36. Red 18. Oh, red's like going to 18. Yeah.
Let's do this
I'm
in
gonna
here
make a
first.
prediction. Okay, so 16 magenta. Okay, 16 blue. 16 blue. That's what we thought. 29 yellow. And 10. Oh, we got it right. Oh,
Okay, we have just a few minutes.
we got it right.
We'll do it after lunch,
Pretty sure I got it
okay?
right. I just got it.
We'll do it after lunch, okay? Leave everything where you are.
Use what you know. Run it. When you get here, use all those numbers, make your prediction, and continue. Everybody must fill out their own sheet.
Oh, stop. Blue butterflies, 17.
You said,
And 36 yellow. 11 magenta. 13 red.
When we go down, there's no yellow butterflies for it, but flowers for it to camouflage itself.
Yeah.
But it's adapting. 5 yellow to be exact.
49 blue. So magenta is automatically 147. That was calculated red.
Let's see what your mistake was, okay?
The data you collected. You ran it 10 times, right? Yeah. You collected data 10 times. Yesterday you added up your butterflies and you found the average. Very good. So now we're going to look at that table. And you're going to look not just at the averages at the bottom, but you're also going to look at the different runs that you did. And we're going to think, what conclusions can I draw from that? How can I analyze this? So this was a really big result. This was a really small result. 15 magenta butterflies survived. And 8 red butterflies survived.
I noticed something.
Well, what is the next thing that I have to write about?
The inference.
I have to inference why.
And I noticed that on my sheet and on that sheet, it's like there's a bigger number and then one that's a little smaller, and then a bigger number and then one that's a little smaller. So maybe there's a pattern, and it was
2, 3, 8, 3, 19, 5. So it could have went to 20, but it was almost to 20. It was almost to 20. Yeah. So let's do our observation inference.
Like the puddle, well, the pond, it will get bigger, but what if it overflows into the streets and everything?
Last night, but when it rains, I want you to watch what happens.
Yeah, the rain is so cool.
That's because it's pollution, right?
What do you think? So I think a lot of you are already really thinking ahead, which is great, on what am I going to need to do to kind of mitigate the pollution? Because right now, what happened right away to the water? Right.
Over here it went down, right? Because over there we didn't have any rain, so it went down, but now it's going up. It like shot up and then shot down.
I was noticing on here earlier when we was talking about the more plants that I push, the less pollution that will go into the lake. But the more plants that I put and the pollution that's coming from the cars will hit the plants, and the plants will start to go away, which means that the pollution will get higher. But as soon as I start placing more plants, the pollution will get lower.
No, the pollutions went all the way down. But it still went.
Those are turning red around the pond, but these like over here, I think it's because they're crowded up together.
So what are you going to try?
To like spread them out a little bit more.
I think with the storm drains, there's less pollution because it keeps it in there so that the things that aren't in there, the grass can absorb. But then the stuff that's in there.